Hey everyone, today I'm going to be showing you what happens when you bring a superconductor next to ferrofluid. And since I bought so much ferrofluid for this experiment, I'm also going to be testing what happens when you pour a liter of ferrofluid on a giant neodymium monster magnet. I have a magnet under my white plate here. Let's put some ferrofluid on the plate. Ferrofluid is made of nanoparticles of iron, and when you apply a magnetic field to them, they follow the magnetic field lines in this spiky pattern here. The stronger the magnetic field is, the closer together the spikes form. So first let me show you what happens when I move a regular magnet near the ferrofluid. You can see it just sucks it up to the magnet. Okay, now let's bring the superconductor up to it. Okay, watch it push the spikes out of the way as I bring it close. That's because it's opposing the magnetic field at first. Now if I were able to get it closer, then it would lock in place and it wouldn't push the spikes out of the way. But if I push it any closer, it's going to go into the ferrofluid. Another cool thing I observed is that when you bring it near the ferrofluid, the spikes actually start to flow towards it. Now this seemed odd to me because there wasn't a reason magnetically why it should do that. So I tested it with just plastic that was cold, not a superconductor, and it did the same thing. So that means it's completely due to the coldness of the superconductor and not the properties of the superconductor itself. That could be because the denser fluid sinks down and the hotter fluid rises up. So first let me lock the magnets in place on the superconductor by pressing it through the magnetic field, and once it's locked there, it will just stay there. So it can spin in one axis, but it's locked in the other axis. Now let's pour some ferrofluid on it. Whoa, that is amazing.